Okay, my report is centered as the Afghanistan's epidemic issue. So I'm going to talk about these five charts. First, let's look at the initial chart, which shows the daily new confirmed cases and new deaths over time, with a 7-day moving average overlay to smooth out fluctuations. We can clearly see that during the early outbreak, those cases and deaths experienced significant variability. However, as time progressed, the moving average helped capture the overall trend of the epidemic. This chart indicates that the epidemic experienced distinct peaks and troughs, reflecting the influence of multiple factors such as testing capacity, capacity and policy interventions and public behavior. And the second chart, uh, uh, it's the 7-day moving average of new cases is annotated with key events such as first reported case, the surge during the first wave, the second wave peak, and the initial of the vacating camping. This visual mapping allows us to see the temporal relationship between these crucial events and the trend in case numbers, while no single event fully explains the overall trend. These marks provide important insights into the turning points of the outbreak. The third chart examines the relationship between the policy strength index and the 7-day smooth new cases by plotting a scatter diagram and fitting a linear restoration model. We observe a positive association. However, the lower double R value suggests that policy stringency alone explains only about 12% of the variation in new cases. This indicates that while stricter policies are associated with higher case numbers, relying on a single director is influenced to fully capture the complexity of case fluctuations. More variables need to be interconnected into multi-factor analysis. Turning to the first chart, this analysis investigates the link between total testing volume and the positivity rate. This is a scatter plot and recession analysis. We find a moderate negative correlation with a person correlation confidence of approximately 0.39. This This suggests that as the number of tests increases, the possibility rate trends to decline. This could be due to more extensive testing, uncovering mild or asymptomatic cases, thus reducing the overall possibility rate. However, it's important to note that variations in testing strategies and target populations across different periods may also influence this relationship. Finally, let's discuss the fifth chart, which compares the mortality rates calculated as deaths divided by cases between two waves of epidemic. This highly significant result indicates that there is a true difference between the two waves' mortality rates. The significant difference might be driven by improved medical interventions, straightened portals, enhanced testing capability, or changes in demographic structure of individuals. It is important, however, to consider that moderate rates can also be affected by changes in case definitions as testing and testing strategies. In summary, my analysis lead to the following conclusions. The epidemic in Afghanistan exhibits clear fluctuations over time with distinct peaks and troughs. Autonoted key events help illustrate the temporal relationship between policy actions and the case trends. A moderate negative correlation exists between testing volume and the positive rate, suggesting that older testing may help lower the positive rate.